Hey guys, how's it going? Today we're going to take a look at the last section of chapter 4. So we're looking at section 4.5, day 1. Now there will be a day 2, so make sure you watch the video right after this for day 2 to finish off this last section, which will finish off our chapter 4. Now, if I sound a little weird today, sorry, I am running a little bit on a cold right now, so I'm going to try to sound as best as possible so you guys can understand me correctly. Okay, excuse me. So let's go ahead and take a look at. Actually, why don't I scroll up real quick? Let's look at our objective for today. We're trying to graph linear inequalities on the coordinate plane. So we've been talking about inequalities in the past couple days, or in the past few days, I should say. But we've been graphing these inequalities on a number line. But now we're actually going to go ahead and graph them on the coordinate plane because we're going to talk about linear inequalities, which are very similar to linear equations. So let's go ahead and get started right away with a linear equation, which is basically a review of before. Now, if we remember correctly, this right here, well, first off, this is in y equals mx plus b form, right? Okay, which is called slope-intercept form, meaning that this is my slope, and this right here is my y-intercept. Okay, so that's how we went ahead and drew this linear equation. So we started at -3, and then I just went on my slope, which is 2, or another way of writing it is 2 over 1. So I went up 2 to the right 1, up 2 to the right 1, or we could do the exact opposite, which is down 2 and to the left 1, down 2 and to the left 1. But we know how to graph that. That's not the hard part here. I know you guys know how to do that, so let me go ahead and erase that. But now, let's think. What are the solutions to this particular equation here? So, this is our linear equation. So when we talk about solutions, guys, what are our solutions? Well, our solutions for a linear equation are the solutions that are on the line. Okay? Any point here, all of these points, so that one, that one, that one, and all over this line, these are all solutions, guys. Okay? Anything that's on that line is a solution to this linear equation. Okay, now that's going to be a little bit different than the linear inequalities. So again, just remember that part. The solutions are located on the line for a linear equation. So let's take a look at what's different on a linear inequality. So here we have y is less than 2x plus 3. So the same thing, we're going to go ahead and graph. And if you guys think about this, we can almost pretend that we're graphing this for a second, which is exactly what we graphed right here, right? The only thing we had to change though, so let me go ahead and erase it now. I just wanted to show you guys how that would be my line if I had an equals, if I had a linear equation. The only thing we had to change, however, is that we have a less than symbol. Okay, not a less than or equal to, it's just a less than symbol. Now, if you guys remember from before, if we had a number line like this, and let's say for example I had a -3 here, I would have to do, like, for example, let me just do an example real quick with you guys. If I had something like y is less than -3, I'd have to put a circle, an open circle, and then shade to the left. Okay, so this is basically what we did for in the past few sections. So we had to put an open circle here. Now, the way we're going to represent open circles here is by making a dashed line. Okay, which is exactly what you see here. A bunch of dashes right here. Okay, all right. So when we have something like this that is not equal to, so if it's not equal to, so again, it doesn't have that little line underneath, so it's not equal to, we would usually use an open circle, but in the case of a coordinate plane, the way that's going to look is dashed line. So rather than doing open circles like we did before on a number line, now that we're graphing on the coordinate plane, we have to use a dashed line. Okay. And then finally, let's go ahead and excuse me. Let's go ahead and talk about this shading here. Okay. Whoops. Let's go ahead and talk about this shading right here. Okay. So if we look at this inequality, we notice that the bottom part is being shaded gray. Okay. Now, how can we tell that from our original inequality? So let me rewrite it here. It says y is less than 2x plus 3. Okay, well, less than, when you think of less than, what do you think of, guys? Do you guys think above or do you think below? Okay, do you think more or less? Well, you think less, so it would be below. Okay, now if you don't get that right away, that's totally fine, but just think about it. If you're talking about having less, you usually want to associate less with lower, right? So that's why when we look at this line right here, this dash line, we want to graph, or rather shade, something that's lower than that line. Well, what's lower than that line? All of this. So let me actually go ahead and graph. So what's lower than this line right here? Anything that's under here would be lower than that line. Okay? So all of this right here would get shaded in. Okay, now it's already shaded on your particular sheet already, so you don't have to shade it in like I just did. But just remember that this remains a dashed line. Okay, still dashed, but we're just shading below because it's less than. Okay, now we're going to talk a little bit more about that in a second. But what I want to talk about right now is the solutions. So, how do you know which ones the solutions are? Where are they located? Well, they're not going to be, well, they might be on the line, but not quite. More specifically, though, this is a solution, this is a solution, this is a solution, this is a solution. Okay, all of these are solutions, and why do you think they're solutions? Because they are on a specific place in the graph. They are on, or rather in, the shaded region. Okay, if they are on the shaded region, then they are solutions. And actually, if you guys start to think about it, that's similar to what we had before, right? If we had something like, oh, I don't know, -2, closed circle, and shaded to the right. And if we asked, is x equal 0 a solution? Well, we start to think about, where is 0? 0 would be over here, be -1 and 0. We would say, yes, it's a solution because x equals 0 is in the shaded region. Okay, so basically I'm just tying it back to what we did before. Same thing applies here, guys. All of this stuff right here, all of these dots that I made earlier, they're all in the shaded region, and hence they are solutions. So anything here is a solution. Now, we have to be careful about whether the points that are on this line, this dash line, are solutions or not, but we'll talk about that a little later, so don't worry about it for now. Okay? Okay, so I just wanted to use that as a quick example. I would go ahead and write this down to kind of give you an example of what I meant by being in the shaded region. Okay, well, let's go ahead and continue on with the next part of this. And again, guys, sorry, I apologize if I sound horrible, but I'm doing my best here. So hopefully this is helping a little bit. So when graphing inequalities on the coordinate plane, solid lines are used for which signs? Now, I'm actually going to do the right hand side first because we already talked about dashed lines. Notice that here on this example, we use the dashed red line because this did not have an equal to sign, right? So I know that the less than symbol will be a dashed line, but also the greater than symbol because it also does not have an equal to sign. Okay, so those dashed lines will be using the symbol less than and also the symbol greater than. Okay, and then notice that the solid lines here on the other side would have to be the ones that are remaining. So the less than or equal to and the greater than or equal to. So again, we usually just use those four symbols with inequalities, guys. So the two symbols that show dashed is less than and greater than. The two symbols that show solid lines are less than or equal to and greater than or equal to. Okay. Now, if we talk about shading, let's go back to this less than. Okay. So less than symbols, which are the less than or the less than or equal to, mean shade. Well, again, look back at this example. We had a less than. And because we had a less than, we shaded above or below. We actually shaded below. Okay. So we're going to shade below for less than symbols and for greater than symbols. I'm sure you guys can guess it by now. Whoops. That's not what I meant to spell. For greater than symbols, we would shade above. Again, just start to think of it in your mind a little bit. If you think of a less than symbol, you think less. What would you think? Would you think below or above? Well, you think below, you think lower, right? And with greater than, you think above. You think definitely have to shade above. Okay. Let's go ahead and actually put this all together into one of our first problems. So let's go ahead and see what we got for number one. It says graph the following inequalities on the coordinate plane. So from here, right automatically, we could start identifying a few things. If you notice this right here, if it were an equation, it would be in a slope-intercept equation. So we could definitely find our slope and our y-intercept, even though it's not an equation, even though it's just an inequality. Same things apply, guys. This is still right here my slope, and this is still right here my y-intercept. So let's go ahead and write those down. So my slope is 4/5. My y-intercept is 0, -3. Remember, guys, it's an intercept. It's a point. So you have to write it as an ordered pair. Okay, so we identified our slope and our y-intercept. Now here is our symbol, which is going to help us determine whether it's a solid or dashed line. So let's look back up here at our little table. That's a less than and equal to sign, which is right here, meaning we have to do a solid line. Okay, so let me erase that now. So we're going to do a solid line. So let's go ahead and actually graph this. So start always at your y-intercept, guys. Start at my y-intercept, and I'm going to go up 4 to the right 5, because that's my slope. So up 4 to the right 5, another up 4 and to the right 5. Or we could do the exact opposite, which is down 4 and to the left 5. So something like that. Now, we're going to use a solid line, so I can go ahead and write, or rather draw, a straight line through all those points. Okay, so there's my line. It's a solid line, so I didn't have to do any dashes. There's no breaks in my line. Now, let's figure out where we have to shade. Now I'm going to go ahead and shade in light blue here. So it's a less than or equal to symbol. So if we look at our two choices, if it's less than, we have to shade below. If it's greater than, we have to shade above. Well, it's less than, so we're going to shade below. So again, if you want, guys, literally just take your pencil and put it on top of that line that you just drew, and just think about it. If it's less than and we're going to shade below, would that be downwards? So grab your pencil, and would it be everything that's under that pencil or everything that's over that pencil? Well, it would be under, so you're going to actually shade everything below that pencil. So this would be your shaded region. Okay? So that is our shaded region. Now, went ahead and put a little area here for a test point that you can try out. Okay, so we left a little bit of space there for you guys to try out a test point. So I'll explain what the test point is. All it is that if we did this whole thing correctly and we have the correct shaded region, then I can pick a point, for example here, that is on the shaded region, and I should be able to test that point out with my original inequality. Okay, so I'm going to pick that point right there. So what is that point? That's a point 5 comma negative 5. Okay, so I see no reason why I can't plug that point into my original inequality and get a true statement. So let's see. My original inequality was y is less than or equal to 4/5 x minus 3. Okay, but now this is my x and this is my y, so I'm going to go ahead and substitute those values in. So I get negative 5 is less than or equal to 4/5 times 5 minus 3. All I did was substitute in those values, okay? If I multiply that out, that's negative 5 is less than or equal to 4 minus 3. Negative 5 is less than or equal to a positive 1. Is that true? Is negative 5 less than or equal to 1? Well, it's not equal to, so that's not right. But it is less than. So as long as one of those two statements is correct, then we are on the right track. So negative 5 is less than 1, so this is true, and hence this point actually does work. So that is a solution to my inequality. Okay, go ahead and try one more, and then I'm going to have you guys try a few on your own. So again, just because it's not an equation, a linear equation, doesn't mean we can't identify the slope and the y-intercept. Again, this whole thing here is in slope-intercept form, so I know this has to be my slope, and this has to be my y-intercept. Go ahead and write down our slope. Sorry about that. So it's negative 1/3, and my intercept is 0, comma 2. All right, now let's think about it. Is it a solid or a dashed line? Well, let's see. It's a greater than symbol, and where do you see a greater than symbol on solid or dashed? It's right here, which means we have to do a dashed line. Okay, so remember, guys, anything that doesn't have an equal to sign underneath it is going to be dashed. If it does have an equal to sign underneath it, then it's going to be solid. So this is going to be a dashed line. So let's go ahead and plot my y-intercept, which is at 0, comma 2. I'm going to go down 1 and to the right 3 because my slope is negative 1/3. Keep doing that. Or I can do the exact opposite, which is up 1 and to the left 3. Up 1 and to the left 3. So now, instead of drawing a straight line all the way through those points, you're going to want to do a dashed line. So still try to go through those points, but you're going to do a dashed line. Still takes those arrows at the end, so make sure you draw those, but make sure it's clearly a dashed line. Okay? Now, once again, we have the symbol y is greater than, so when we look at our table again, less than symbols we shade below, greater than symbols we shade above. So again, if you grab your pencil real quick and you put it right over that line we just drew, then we would have to shade where? Above that pencil. So, because it's greater than, we shade above, which would be right up here. So anything above this line. Okay, so just go ahead and grab your pencil and start shading that in. So this right here in pink on mine is a solution set. Okay, so all of those points that would be on that pink area would be my solutions. So let's actually test one of them out. Now, I'm going to just go ahead and grab a point here. So go ahead and try it out with me and check your work. So I'm going to assume that my work is correct. And if it is correct, then I should see no reason why I can't pick, like, let's say, oh, I don't know, this point right here. Okay, so 3, comma 5. That's in my shaded region, right? So that one should give me a true statement if I substitute it into my equation. I don't know, I just scrolled up. Okay, there we go. Alright, so let's go ahead and substitute that into my original equation. Or, I'm sorry, my original inequality. Sorry about that. So let's go ahead and... So I just rewrote my original. But remember now, this is my x, this is my y. So if I test that point out, what I get 5 is greater than negative 1/3 times 3 plus 2. So this is still 5 is greater than negative 1/3 times 3 is a negative 1. And negative 1 plus 2 is just a positive 1. So is this statement right here, 5 is greater than 1, a true statement? And we know that in fact that is true. Okay, 5 is greater than 1, and so my shaded region is correct. Okay, so that's all we're doing here, guys. We're going to go ahead and decide whether we are using a solid or dashed line. Once we have that, we have to decide, are we going to shade above or are we going to shade below? Okay, finally, once you have all that done and you have all your line graphed and you have your shaded region all shaded in, you have to actually test out a point. So just grab a point that's in that shaded region and see if it actually works out by substituting it back into your original inequality. Okay, what I want you guys to do is to try out number 3. So go ahead and pause the video right now and try that one out. Alright guys, let's go ahead and see if we can do number 3, and then we'll move on to number 4. So once again, number 3 is in slope-intercept form, and just because it is not an equation and now it's an inequality doesn't mean we can't identify that. Okay, so our slope is still just 3, or if you want to write it down as 3 over 1. Alright, and our y-intercept is still, again, always make sure you write it as a point. So it's 0, comma negative 5. Now, is it a solid or a dashed line? Well, again, notice it does have this little equal to symbol underneath it. Okay, and because it has that, then we know it has to be a solid. Okay, it is a solid line. So let's go ahead and start graphing it. I'm going to go to 0, comma negative 5. I'm going to go up 3 to the right one, up 3 to the right one, and just keep doing that. Or I could do the exact opposite, which is down 3 and to the left one. Okay, so now take your pencil and draw a solid. You don't need to do dash this time. It's actually a solid line. There's my best attempt at a straight line. If you have a straight edge, make sure you use it. Okay, now we have to figure out, are we shading above or below? Well, again, the symbol is y is greater than or equal to. Greater than or equal to. So when you think of greater than, do you think above or do you think below? Okay, you should probably be thinking above. Greater than is above and less than is below. So in this case, we have greater than, so we're going to shade above. Now, it doesn't seem too clear here which side is above, but if you think about it, this is almost like on a slant. So if you take your hand and you put it directly on that slant, if you move your hand to the left, it's almost like it's going to the left and up. But if you move it to the right, it's going to the right and down. Okay, so we want above, so we want up. So we're actually going to shade to the left. If this for some reason does not make sense, guys, if you're not getting why we're shading to a certain direction, please make sure you ask. Okay, I will be more than happy to help you guys out with figuring out which way you have to shade. Okay, so that is my shading region. Okay, now all I have to really do is pick a point to test. Now, what I'm going to do is I'm actually going to pick, let's see, what would be a good point to test out? Well, how about this? we've talked about this before, or at least I mentioned it at the beginning of this video. Sometimes the points that are on the line that you graphed may be a solution, sometimes they may not be a solution, okay? So what I actually want to test out is this point right here. I want to test out that point right here. That is the point 0, comma, -5. Now, that doesn't look like it's on the shaded region because it's directly on the line, okay? But let's see if that qualifies as a solution. So let's actually substitute it into my equation, or I'm sorry, my inequality. So my original inequality was y is greater than or equal to 3x minus 5. Okay, so now if I substitute my values in there, I really have -5 is greater than or equal to 3 times 0 is 5. So -5 is greater than or equal to -5. Is that a true statement right here? Is -5 greater than or equal to -5? Well, it's not greater than, but it's definitely equal to -5. -5 is equal to -5, so this right here is a true statement. So notice what we needed, guys. If it would have just been -5 is greater than -5, it would have been incorrect, okay? That would have been wrong. But because we do have that equal to symbol, okay? So -5 is greater than or equal to -5, then it is true because -5 is equal to -5. So what does that tell you? That tells you that in order for the numbers or the points that are on the line to be solutions, you have to have this equal to part, okay? Meaning that if you have that equal to part, then only solid lines have solutions on the line. So only solid lines have solutions on that line. If we would have had a dashed line, this would not have worked because we would have had something like just greater than. We wouldn't have had an equal to. We would have just had -5 is greater than -5, which would not have been true. So something, a point on the line that is dashed would not work. However, a point on the line that is solid would definitely work. Okay? Again, if you want to test out another point, guys, you're more than welcome to. I mean, you could easily test this point out and see if your solution set or your shaded region is graphed correctly. Okay? Okay, so let's go ahead and move on to number 4 here. So what number 4 tells us is that we have x is less than 5. Now, I'm going to, before we move on to that, I want to figure out if you guys remember how to draw that. X equals 5. How would you draw that line? Okay, well, you guys remember that if it starts with x equals, then it has to cross the x-axis, meaning it has to be a vertical line. So x equals 5 would be right here. Only difference is that this is not saying x equals 5. This is saying x is greater than 5. So it's going to look similar to the one I just drew, but because there's no equal to underneath, then it's going to actually be a dashed line. So this is my, let me color because you can't really see that. Oh, you can't really see that one either. Let me do a light blue. So we have a dashed line. Okay, still diagonal, but it's a dashed line this time. Now, if you think of less than, do you think, again, do you think above or below? Well, you think below, but in this case, you only have a left region and a right region. You don't have an above or below. So this is a little tricky. But again, I'll take you back to what we originally learned. If you have this, you have an open circle, which again, open circle means we're just going to have a dashed line. But which way would you have shaded if you had just a number line? Well, again, if you think of this as like an arrow, it's pointing to the left, meaning you have to shade to the left. So you would have shaded to the left here. So it's the same scenario here. on the coordinate plane. If you're on x is less than 5, then you actually have to graph and shade to the left of that line. So this would be your shaded region. So anything to the left of that line would be your solution set, just like anything to the left of this point would have been my solution set. Okay, so again, if you want to go ahead and test out a point, you're more than welcome to. Let's go ahead and pick, oh, I don't know. Well, let's pick this point right here. What's that point? That's 0, 0. So let's go ahead and substitute 0, 0 into that inequality. Well, the only one I can substitute there is the x, right? So this would be 0 is less than 5. Is that true? Is 0 less than 5? Yes, of course it is. It is true, and so my shaded region is correct. I did have to shade the left. Okay? All right, so let's go ahead and, oh, I think I missed a few things here. Let's actually go ahead and check these test points out. So for number 3, it says, is 0, 5 a solution? Let's see. 0, 5 is right up there. 0, 5. Is it a solution? Let's test it out. Well, we know it's in the shaded region, so I'm going to go ahead and say yes. But if we wanted to test it out, let's go ahead and substitute those values in. This is my x, this is my y. So I have 5 is greater than or equal to 3 minus 5. Is this statement right here true? Yes, it is. It is true. 5 is definitely greater than or equal to negative 5. So yes, once again, not only did I tell that it was a solution because it was in the yellow region that I shaded, but even after testing it out, it gave me a true solution. So let's test out this one for number, let's see, what number was this? Number 4. So is negative 3, 5 a solution to this particular inequality? Let's see, where is negative 3, 5? That would be right up here. So is it a solution there? Well, let's see. It's already on the yellow region, so I'm assuming it is going to be a solution because it is already in my shaded region. But even if I test it out, again, this is my x, this is my y. So if I substitute it into my original inequality, this would be negative 3 is less than 5. Is that true? Yes, it is true. So once again, those solutions are part of my solution set. Okay. Number 5, I want to go ahead and do together with you, and maybe I'll let you try out 6 or 7 on your own. But let's go ahead and take a look at number 5 together. So, number 5 says, we have 6x minus 3y is greater than or equal to negative 18. All right. Well, that doesn't tell us my slope or my y-intercept, but we know that we can turn this right here into a slope-intercept inequality. Okay, right now it's in what form, guys? Hopefully you guys remember what that's called. If both variables are on the left or both are on the right side, that is in standard form. So let's switch it now to slope-intercept form, meaning we want something to look like that. So we have to get the y all by itself. So let's get rid of that 6x. Okay. And now I want to divide by negative 3. But remember, what's that special rule with inequalities and multiplying and dividing by a negative number? We have to flip. So this is going to be y is now instead of greater than or equal to, it's going to be less than or equal to negative 6 divided by negative 3 is a positive 2x and a positive 6. Now we can identify our slope and our y-intercept. This is my slope. This is my y-intercept. So my slope is 2 over 1. Y-intercept is 0, comma 6. All right. So in the meantime, guys, what I want you to do is now that I have my actual equation, I'm sorry, I keep saying that, but I keep correcting myself because I need to make sure I use the correct vocabulary, guys. This no longer is an equation. This is an inequality. Okay. So if you hear me saying equation, correct me, okay, because it is an inequality, okay? I know I've been catching myself a couple of times, so make sure you're catching yourself as well if you are saying it the wrong way. Okay, so now that I have my inequality in slope-intercept form, why don't you go ahead and graph the y-intercept, use your slope to graph your line, figure out if it's solid or dashed, and go ahead and find which side you have to shade, okay, above or below. So go ahead and try that out while I go ahead and grab my charger. Alright guys, I'm back. So now I have, sorry, I had to go get my charger while you guys tried that out. So let's go ahead and see if we can figure out how we can graph this. So first things first, we had to go ahead and graph our y-intercept. So we have a y-intercept at 0, comma 6 right up there. Now we're gonna use our slope to go ahead and graph the rest of the points. So the rest of the points are up 2 to the right 1, up 2 to the right 1. Whoops. Sorry, up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1, down to the left 1, and you could keep going on and on. Now, I'm not going to go ahead and draw the rest of the points, but from the inequality symbol we're using, which is less than or equal to, are we going to use a solid or a dashed line? Okay, so hopefully you guys have figured out that it's a solid line because we have that little equal to symbol there. Anytime you have the equal to symbol, you have to use a solid line. Okay, so I have my solid line there. Now what I have to do, now I just have to figure out where am I shading, above or below. So in this case, I have less than, okay, it's a less than symbol, meaning I have to shade below. Well, which way is below? That would be anything under that line. Anything under that line is a solution. Okay. All right. Now, let's see. Should we get a test point here? Let's see. Oh, it already asked us for one. So it says, well, first off, let me go ahead and finish this off. This was a solid line, and we shaded below. It says, is negative 5 comma 6 a solution? Well, where is negative 5 comma 6? Negative 5 comma 6 would be right up there. So right away, we know right there that it's not in the blue shaded region. So I'm going to assume that the answer is no. Okay? But let's go ahead and actually try that out. Now, you can try it out in the original equation here. See, I caught myself again. You can try it out in the original inequality right there. So let's go ahead and test it out in that original inequality. So what I'm going to do is substitute in my values, my new x and my new y. So I'm going to do it right here. So if I had 6x minus 3y is greater than or equal to negative 18, that was the original. But now I have a new x and a new y, so I'm going to substitute those values in. So this is 6 times negative 5 minus 3 times 6 is greater than or equal to negative 18. 6 times negative 5 is a negative 30. This is a negative 18. And another negative 18. Now I get negative 48 is greater than or equal to negative 18. Is that true? Is negative 48 greater than or equal to negative 18? Well, that is not true. That is not true. Negative 48 is not greater than, it's actually less than negative 18. And once again, because it's not true, that means it's not a solution, which would make sense because it was not anywhere in our shaded region. Okay, so hopefully it's starting to make sense, guys, that you can test it out both ways. You can actually test that point by substituting it back into the inequality to check if it works. Or you could just check where it lies on the coordinate plane. Here it was all the way out here in the white area, okay, which was not anywhere near all of this, which is all of the shaded region. Okay, good. So let's go ahead and look at these final two problems, and we will be done for the day. So now, this is a little bit different. Now I actually have the graph. Now I'm trying to figure out what the inequality is. Well, what did we need before when we were actually drawing the graph? We needed slope. We needed a y-intercept. And we needed a symbol. By symbol, I mean we needed a less than or a greater than or less than or equal to or than or equal to. Okay, and from there we were able to determine whether it was solid, dashed, shade above, or shade below. Let's go ahead and write down a few things that we do now. Okay, so right underneath where I'm going to put my answer, I'm going to actually write M for my slope, B for my y-intercept, and then I'm going to talk about whether I'm going to shade above or below, or whether it's a solid or dashed line. So from here, remember, we always needed to find the y-intercept first in order to start graphing, so that's what I'm going to look for right now. Where is my y-intercept? It's right there. That's at 0, comma, -2. So my b here is going to be a -2. Remember, I'm going to need to write it in this form. Okay? What is my slope? Well, from that point to this other point, what would I have to do? Travel up 1, 2, 3, and run 1, 2, 3, 4. So up 3 and to the right 4 gives me a slope of 3/4. Now, we have a few choices. Again, we have that symbol, so less than or equal to, or we have greater than or equal to. Now, let's figure this out. We have a dashed line, meaning which two choices are already out? Okay, again, we have a dashed line. It's a dashed line, meaning which two symbols are out automatic? Those two are out. Okay, we cannot have either of those two because they have an equal to underneath them. Because they have an equal to underneath them means that we would have had to have a solid line, but we don't. Okay, so the only ones left are less than or greater than. Now, we shaded which way? Above or below? We actually shaded, whoops, below. We shaded below. Which one of these means below? Less than or greater than? It would be less than. So this one is also out. Now I have everything I need. Again, I need something in this form. Now I have my symbol, my y-intercept, and my slope. So I'm going to start with y, my symbol, which is less than 3/4 x minus 2. I have officially written my first inequality given the graph. Okay, so we're going to do the same thing for number 7. So what I want you guys to do is to try it out on your own. So same thing, guys. Figure out your slope, y-intercept, and symbol. Okay, so look at all the clues that you're given on number 7, and then see if you can come up with something in this form. Okay, guys? All right, go ahead and give that a shot. All right, let's see if we can figure this one out. So right away, I have to remember, always find your y-intercept first. That's right here. That's at 0, comma 6. So my b here. So that's again 0, comma 6. So my m, my b. So my b is a positive 6. My slope, well, let's see. From that point to this next point, I have to travel down 1, so -1, and to the right 1, 2, 3, 4. So my slope is -1/4. Okay, now again, I have a few choices here. I have that symbol, less than or equal to, greater than or equal to. Let's figure out which one we're going to use. Again, look at your line first, guys. Is it a solid or dashed? It is a solid line. So which ones are automatically out the table? Those are off the table. I cannot use either of those two. It's a solid line, so it means it can only be a less than, I'm sorry, an equal to, has to be underneath the inequality, so it's only a less than or equal to or a greater than or equal to that are our choices. But we also know that we are shading above. So which one of these two means above? That would be this one, greater than, okay? So that one is also out. So now I have my symbol, I have my y-intercept, and I have my slope. So I can write my inequality. So that would be y. And actually, let me do a different color so we don't get confused. It's going to be y. Again, my symbol was greater than or equal to. My slope is negative 1/4 x plus 6. And there we go. Okay, so y is greater than or equal to negative 1/4 x plus 6. All right, guys. So again, let me just recap what we did today. We talked about how graphing linear inequalities is very similar to graphing linear equations. The only difference is that now, again, these two look very similar. The two lines look very similar. However, we notice that sometimes we'll have dashed or solid lines, and then we will also have shading. Whether it's above or below, we have to figure out according to the symbol. That's what we have here. Solid lines take the less than or equal to and the greater than or equal to. For dashed lines, it's just the less than and the greater than symbols. Okay. When we have less than symbols, which are the less than or equal to, we have to shade below. For greater than symbols, we always shade above. Okay. So now, given all of those hints, we were able to graph all of these inequalities. And then finally, in the very end, we were actually able to do the exact opposite, which was take the inequality that was already graphed and find its original inequality in algebraic form. Okay? All right, so I think I'm going to go ahead and pause the video right now, and you guys can go ahead and move on to doing the homework, or if you already have that done or are almost done with it, you can go ahead and move on to 4.5 day 2. All right, guys, I will talk to you soon. Here, bye.